Hi, everybody. Welcome to Growing with Climate Change. I'm just brief introduction. So welcome. This is a presentation that's being put on by the Concord Ag Committee and the Concord Public Library. We're first going to have Erin Lane talk. She is the Deputy Director of the USDA Northeast Climate Hub. So the mission of the Climate Hub is to develop and deliver science-based Northeast-specific information and technology to agriculture and natural resources managers that enable climate-informed decision-making. So Erin specializes in climate adaptation strategies and wildland fire and climate change. She is also the co-founder of the North Atlantic Fire Science Exchange. So Erin, if you are ready, we're ready for you.
Fantastic. Hi, everybody. Sorry I can't be there in person. I would have loved to be there and see you all, but hopefully this will work out just fine. And we'll have hopefully some time for questions at the end and some engagement discussion with the farmers. So as mentioned, I'm a climate ecologist and I actually work for the U.S. Forest Service, but don't be caught off guard with that because the Forest Service just hosts one of the climate hubs. I actually end up working more with agriculture than I do with forests these days. And I'm going to give you a little bit of an overview on the climate hubs, just to get you kind of oriented with what we do. And then I'm going to spend most of the talk talking about climate change impacts to agriculture, as specific as possible to Massachusetts, but really a lot of it's going to be regional impacts. And then we'll bring it back to the Climate Hub just a little bit to talk about some of the projects that we do that may or may not be of interest to you, but I'm just gonna give you a few to give you a sense of what we do. And then I present a bunch of resources and tools that, again, it's a variety, so you can pick and choose what interests you. Just a quick check-in. How do I sound to everybody? Is it okay? And can everybody see just fine?
Is it possible to be a little bit louder?
Yes, I can. It'll be like shouting, but is that okay?
Sounds good.
Okay, I am shouting, but that's okay. I don't mind. All right. So, the climate hubs. We're going to start with this introduction. We have been in existence for 10 years. We started with Obama's Climate Action Plan in 2014, and I've been with the Climate Hubs that whole time. It was a shift from my career in fire.
Erin, just a heads up, we were able to up the volume, so I think you don't have to shout.
I am so glad.
You sound great now. Thank you.
Phew, thank you. I was like, this is going to be tough, but I can do it. Okay, I'm okay now. Great. I was thinking, I'm talking pretty loud, so hopefully they can just turn up the volume. All right, so don't be afraid to adjust me as I'm going. Our mission was mentioned in the beginning here, but I'm just going to repeat it here. We are all about delivering, developing, research-based, evidence-based scientific information that's specific to our region. And it's all about enabling decision making. So helping farmers, foresters, other producers, other stakeholders deal with climate change. And that's on working lands and waters. So we're really pretty specific to farms and forests and to some extent aquaculture as well. Okay. And this is a one USDA project. We work very closely with the Agricultural Research Service and the Natural Resources Conservation Service. So you're going to hear me talking a lot about NRCS. We have some projects with them of late. We also work with Extension and Land Grant and some nonprofits. We work with NOAA and others as well. So very USDA centric, but trying to partner across agencies and across with other partners. So what we do is we support the development of research, but we also support this idea of synthesizing research. So bringing together data from various sources, making it make sense, making it more accessible, translating, demystifying. We do this, the second kind of way that we work is through developing and supporting the development of tools, like decision support tools, technology, anything that can help producers or technical service providers in planning and decision making. And then lastly, we do quite a bit of what we've called convening, bringing people together, not just data together, but people and partners, who's working on what, and can we all get on the same page? So that's outreach, training, education, kind of a facilitating engagement around these topics. Our priority issues have shifted over the years. We have worked primarily in the realm of adaptation. How do we build resilience to the changes that we've already seen, and how can we continue to I like your title, grow with climate change. I love that. I was like, that's a good one, because we need to adapt and we need to grow as climate change is happening. And then a recent focus, which we have focused on in the past and we're focusing on again, is climate mitigation. How can farms and forest management make a difference in reducing greenhouse gas emissions and increasing carbon sequestration? So that is a recent focus that we have taken. I'm going to talk a little bit about the rest of these too, and like climate literacy and environmental justice as well as we go. So what does it mean? Like, what does it actually mean that we do? Well, we produce, we have a lot of meetings like this, a lot of presentations like this, training, that sort of thing, peer-to-peer learning. We also have fact sheets. We have economic case studies, newsletter, which I'm going to encourage you all to sign up for, workshops. That's kind of the convening part, or can be a research oriented as well, webinars, and demonstrations. That's what it looks like. A lot of that's on our website. Okay, that was just a little introduction to the Climate Hub and what we do. I'm now going to talk about the impacts that we're seeing in the Northeast. Now, a lot of this is familiar. I know it's familiar. You're here because you know the climate is changing and you know how the climate is changing. But what's interesting is that it's not having the same impact across the country. It really affects different part of the country differently. And so I'm focused just on the Northeast here. And then I'm going to give you some resources so that you can figure out your state and your county. So we are seeing the increase in temperatures with global warming. That is a thing. One thing that's happening here is it's not so much the maximum temperatures that have increased yet. It is that it's not getting as cold. So winter temperatures are increasing, nighttime temperatures are increasing. So that is still warming. Do not be mistaken. I had somebody come up to me after a talk once and they were like, global warming, it's not a thing, because it's not actually getting hotter. It's just not getting as cold. I was like, that's still warming. That has a lot of impact on ecosystems, okay? And we are also seeing that heat waves are worsening in our region, and I think that's because we have so much urban issues. Like the urban areas experience that more intensely, and that is an issue for us. We're seeing an extended vernal period, which in my neck of the woods, I live in Vermont, we call that mud season. And mud season used to be a lot shorter. It's really expanded as winters are warming. I wrote heavy snowfalls. That is a mix, right? We're actually seeing less snowpack, and I'm sure you saw some of that this winter. But with that, we are also getting just as, if not heavier, snowstorms every so often. So it's like it's being held in the atmosphere. And then dumping all at once. Similar to the rain that's happening, we're having an increased precipitation across the region and across seasons, and they're coming in bigger events. Drought doesn't seem to be increasing, and we can discuss that more, because I know that will perk up some ears in the room and say, oh, I think it is. And I'm not going to question that. I think that it's not there in the data yet. And then I'm going to just do a brief brief mention of sea level rise, because I know you guys have some coastline there. So starting out just focusing on temperature, okay? Average temperature, I said minimum temperatures are increasing, but that means average temperatures are increasing. And they have increased. It depends on where you are in the region. It's 3.5 degrees Fahrenheit since the 70s. You're going to see a bigger number if you're looking at further back. And then you can see that trend there, that blue line, just really on a steep incline and continuing, projected to be continuing to rise. And a lot of that is happening in the winter. I haven't gotten a good graph of any state but Maine here, but this is Millinocket, Maine. And you can see the x-axis there are months of the year. So you got January, February, and then that's how much change in temperature we've seen. So you're seeing it in the winter, and then we don't really see much in the summer, and then it starts going up again in fall, and then shoots up November, December. So really, winters are warming more than other seasons, and you can see that in the average temperature trends for winter graph. And that all of New England is, and a little bit of New York is it's so red, and that's not happening in the rest of the country, right? Like, you know, some of it in Montana, Upper Dakota, but it's certainly a northern issue. And this is something that matters for agriculture, right? So the growing season in the Northeast has increased by 14 days. And the number of growing degree days have increased by 15%. So we have a tool, and I know this is it's an out of place tool, but I put it on this page because it's so interesting, that shows trends in last spring freeze, first fall frost. I mean, that matters a lot, right? That matters for planting, that matters for harvesting. So shown here where the darker orange is plus 5 days for between those frost dates, okay? So in recent years, the final spring frost has been occurring earlier than at any point since 1900. And then the first fall frost has been arriving later. This freeze date tool is kind of cool to use. I think it's actually a Midwest Climate Hub tool, and it's on Purdue's website, but you could probably find it by just saying freeze date tool. And another way that we're experiencing the shifting temperature dynamics in the warming average annual minimum temperatures. This minimum temperature is critically important for determining what plants will survive the coldest winter conditions in any given place. We use these temperature trends in this way that you're likely familiar with, plant hardiness zone. So we, meaning USDA, create the plant hardiness zones based on this information. Anyone who has put a tree or planted a perennial in the ground is likely familiar with this system. And what you may or may not know is that these zones are based on 30-year average temperature trends. And so as the winters warm, we hit those low temperatures less regularly, and that is reflected in the plant hardiness zones. The USDA just recently released this new plant hardiness zones, which it's a finer, they use a finer resolution for spatial data, and they use data from more weather stations, more sophisticated modeling, and it showed that half the country warmed to a degree that it shifted at least a half of a zone. So if before you could plant plants that were rated to 8A, you can now likely plant species that could survive in 8B, and that's reflected in this. I mentioned this earlier, growing degree days. I would say that many of you probably already know what growing degree days are, but I only learned this in the last few years, so I'm going to explain it, so that we can all be on the same page here. Growing degree days are also known as heat units, and so we use them to estimate when any given growing season crop will develop, or when a pest or another insect may go through a different life stage. We use this simple formula that's on the slide here for keeping track of the growing degree days. So basically you take the max temp for any given day and you add the min temp for that day, and then you divide by 2. That gives you the average temperature for a 24-hour period. Then you subtract what we call a base temperature. Most of the time we use a base temperature of 40 to 50, but it can be anywhere between 30 and 50. Different species have different base temperatures. You could look those up. And that equation gives you growing degree value for a single day. So then you start on January 1st, first day of the year, and you just keep adding your growing degree day values one on top of another. So May 1st, you might have 72 growing degree days accumulated, just as an example. But by July 1st, you might have 900 because there's that warmer period of growing degree days. And then how do you use this information? You can take the example of spotted wing Drosophila as an example. So we have past studies. We know that the first generation of the adults are likely to emerge at 510 growing degree days. We have the research on that. And then they peak at 755. So you should theoretically have monitoring traps set out before the 500. And if you're keeping track of them, then you know as a precaution when you can set up these traps, and you can keep tabs on the population pressure for this pest. So there's really good forecasting tools that are used to predict or forecast growing degree days and then estimate what they are as well. So you don't have to keep track of it yourself. And that's there's online calculators that can do that. One of them is called the Climate Smart Farming Growing Degree Calculator. There's another tool I talked about. I slipped in there. Okay, just wrapping up temperature here. I like to think about sea level rise, and we have been doing some research on salinization of plants that occur and the need to either change what you're planting on the coastlines or I think of salt marsh hay, for instance, which is, if you were growing something else, you might want to consider that as a new crop if you're in that zone that's having more salinization due to sea level rise. And it's not so much the sea level rise; it's also more about the combination of sea level rise and storm surges, and that's causing the issues. And we see that with forests too, in ghost forests, for instance. Okay, so that's temperature. And now we're going to move into precipitation. So with an increase in CO2 and the other greenhouse gases in the atmosphere, that's causing radiative forcing. And that results in global mean temperature rise, which we just talked about. But for each degree Fahrenheit that we increase temperature, the atmosphere can hold 4% more water. So you can add that up with how many degrees Fahrenheit we've increased. And then with Celsius, it's 7% for each degree Celsius, right? And this means that the intensity of storms is increasing. It's just a bigger bucket, can hold and dump more water. A warmer atmosphere holds more water vapor and therefore dumps more water when it rains. So precipitation in general is increasing. This is more alarming really than temperatures for our region. So if you look at that graph, it's for summer, shows an increase of almost a half an inch per decade since 1960. But this is similar for other seasons as well. And in fact, it's different studies say different things about which season is seeing more. And it also depends a little bit on which state you're looking at. But I can point you to some resources to figure out for Massachusetts. And you can see that it's not happening everywhere in the US. So if you look at this map, the US has had the largest increase in the number of extreme precipitation days, which is the top 1% of the heaviest rain events. That's occurred in the Northeast. And this is again in all seasons. And if you look on the graph to the left, this is showing the intense rain events. So for flooding, we think a lot about how much rain comes all at once. And in the upper left there, that's 2 inches of rain in a day. That's increasing. I want to say by 50% compared to the long-term average. Yeah, 49%, it says that. If you can read that in the corner there. This is from the National Climate Assessment. In the lower right-hand corner, you can see days with 5 inches of rain or more are really increasing compared to the long-term average. That's over 100% increase. So if we're getting more rain, but we're getting it more in one event or all in one day, does that actually mean that we could have more drought? I get this question all the time. And drought is one of those things, and I have that question too. Drought's one of those things that can be difficult to define. So I think it's important to just bring up the different definitions. It can be somewhat subjective: supply and demand, lack of precip, deficit of surface runoff, moisture supply. And all of these different, it depends on the user, right? It depends on the reason or who's seeing the deficit of what kind of drought there is. And long-term records show that conditions are becoming drier in much of our country. You can see that on the map. That's much of the West, though, and it's really showing wetter everywhere else, and that's particularly in the East. That's the blue or the blue-green on the map. And averages across the region are this blue, but we're seeing geographically isolated spots of drought in real life, right? When you're not looking at this map, when you're just thinking about your backyard, you're thinking about your experiences. We're hearing this experience of more drought, but we are not seeing this in the data, and it's not, and I'll show you. Here's a great example. Dry days, number of dry days are actually decreasing in the Northeast. That's green, right? Negative, decreasing. The brown is increasing. And dry days is one measurement of drought, and there's a lot of different elements that come into play there. This is a good study that I used that showed, okay, but we still have drought, and it's not decreasing as much as might be expected with all that rain. So if you look in the frequency graph, that's the top one, kind of look at Massachusetts there, you can see it's pretty blue. So drought frequency is decreasing. It's decreasing. And then you look at intensity, that's in the bottom left. Yeah, there's some yellow and red in Massachusetts there. And so maybe the droughts are getting worse, but aren't as frequent. I mean, this is what this study is saying. And these bullet points are actually regional, but I'm looking at Massachusetts right now. And then duration is kind of a mix, right? Mostly decreasing, a little bit of increasing there. Okay, so that's giving us a little bit more of the story. We actually are so curious about this that our hub did an analysis with the National Drought Mitigation Center, where we analyzed drought trends across the Northeast. And what we found was that, yep, increase in precip, and in this study, it was winter and spring that was really the most prominent. But again, no clear dry period increase, or no clear change. Maybe a little bit of an decrease in the dry periods. Decrease in snowpack. However, generally a decrease in snowfall, but some increase in snowfall, especially in the inner mountain regions. So I mentioned that earlier. Not a lot of clear answers, but we're still working on it. One of the things we're thinking a lot about is precipitation effectiveness. So, okay, we're getting the rain, but we're getting it all at once. So is it useful to the plants, right? And if you measure soil moisture and you track that gives us a better answer, but that's hard to track. It's hard. It's a harder way to measure. It's a harder thing to measure, especially on a regional scale. So I do think that this could be a key to understanding drought and also things like fire risk. We see that projected change in summer soil moisture by mid-century, as compared to the last 30 years, is a decrease in soil moisture. Like this is projections. This is not necessarily trends. But that does make a lot of sense, especially when we think about evapotranspiration. And the evapotranspiration is increasing, especially in humidifying areas of the country, because we're actually seeing more water. So the more water is available to be evaporated and used by plants. And that can also affect how drought plays out in our region. So that kind of wraps up the climate change part of it. My next section is agricultural impacts. And I don't like to dwell too on this, because if we have farmers in the room, the farmers know these stories and can tell these stories much, much better than I can. But if we're seeing an increase in rainfall, then we're going to be seeing an increase in erosion and compaction and loss of nutrients, crop losses. We see an increase in temperature. There's this false spring that happens, especially with perennial crops, where it's super warm in February, so the trees decide, yep, they're gonna bloom, and then it's regular old cold temperatures in March and they freeze. So we saw that quite a bit in like Pennsylvania in 2012 with the peach trees. We saw it with apple trees recently, a couple of times in the last decade. So that is actually one of the biggest impacts that we're seeing. And there's also this, like, remember we said, okay, well, there's more rain, but how do you collect all that rain and use it for other times of the year when it's not as wet, right? Because again, we're not seeing as much decrease in drought as we would expect. There's the growing season increase is great for some things, right? There's opportunities there, double cropping opportunities. We've seen that happen, but there's also an increase in pests and weeds with that increase as well. And we're seeing yield issues, and I mentioned the salinization. So how do we deal with this? And the answer is a lot of it is the same strategies that we use, that we've always used in soil conservation, in agroecology, in being good farmers who are trying to increase yields and economic reasons. The same sorts of things are going to apply, and farmers are already adapting. Right? There are some innovative strategies. There are some sort of newly emerging strategies that are coming along, and we do try to stay attuned to those as well. But here's some examples on this slide. And this is nothing new, right? Much of what we already do for general conservation practices offer this increased resilience to changes in the climate. So, for example, using any of these conservation tillage methods can be part of the strategy to improve soil structure, which increases the resilience to variability in the weather. Another example is covering crops. We know that buffers soil temperature. It also preserves moisture or buffers from too much moisture. It also provides more of those living roots, carbon, organic matter in the soil, and protects against erosion. So I skipped through those really quickly because I'm hoping that we'll hear more stories about that from the farmers. Next, I'm going to talk through just a few of the projects that the hub has, because I'm hoping to spark some connections or interest in the group. So just have a couple of examples here. One is that we have been focusing on advancing climate equity. We understand that climate change is affecting people differently, and in our region, we are in the process of identifying what those issues are in our region and what some of the key strategies are to address those issues. So one of the ways that we're doing this is we hosted a graduate scholar program where we brought together PhD and master's students who are working on agricultural and forestry adaptation in the region, and then kind of asked them to put an equity lens onto their research and provided them resources to do so. With that came a series of climate equity webinars. We're engaging a tribal equity fellow address some of these same issues specific to tribes. We have an art and climate equity project as well, and developing a toolkit. Our climate equity fellow has been working on a adaptation toolkit that's specific to this equity question. This is just an example of an innovative tool, practical tool that we're testing. We're partnering with USGS and some folks at University of Maine to explore this technology of a shallow well, so it can provide an additional source of water to growers. So in this case, this could be a cost-effective method to kind of keep capturing the water that we're getting in the precip and being able to use it to continue yields when things are drier. We have a peer-to-peer learning program that is focused on climate adaptation and mitigation, where we engage fellows that are like a farmer fellow, and a technical service provider. We pair them, and they go through a process of creating adaptation plans and learning about climate communications and how to talk to their peers. And then they do outreach on topics that they choose that are related to adaptation and mitigation. And we had a few of the fellows in the diversified, we started with a diversified specialty crop program, and now we've moved on to dairy. There's a women in non-binary group, row crop group as well, that are working through a curriculum and engaging in this fellowship. I know I've mentioned climate mitigation a few times. We are just starting this rather large project with NRCS to increase their climate literacy, to help them implement this new set of conservation practices that are specific to reducing greenhouse gas and improving soil carbon sequestration in general. and this is funded by the Infrastructure Reduction Act. And as you may know, that's gotten quite a bit of attention through NRCS, but our job is to kind of help get the research, the evidence behind these practices, so that we can understand how they affect yields and how they truly affect climate mitigation, verification of that reduction in greenhouse gas emissions. I'm going to move into the next section of the presentation. It's my last section of the presentation on decision support tools and resources. So I'm just going to share a few of my favorites. There's actually a lot that are out there. Forgot to change this to Massachusetts from my last presentation, but this is NOAA state summaries. These are, if you haven't seen these before, I recommend you just go online and download the one for the state of your interest. It's 4 pages. It gives you a lot of the graphs that I gave you specific to Massachusetts. It'll tell you kind of what the increase in temperature is, what seasons are increasing precip, that sort of thing. Highly recommend this as a synthesis of how climate is changing in your state. Ag-risk viewer is kind of fascinating if you're interested in crops and what's at risk in your region. So you can search by county, for instance, and the purpose is to allow you to explore, visualize, and analyze crop insurance data. It's all publicly available from USDA Risk Management Agency. You do these analyses to see what is being damaged and why. Selector can be used to identify cover crop species that are most appropriate for any given field. And the user inputs your goals. So it could be like improving organic matter, preventing erosion, nitrogen fixation, and your location, and then gives this tool selects for you what your options are for cover crop. It's a pretty cool tool and encourages cover crop use, which has many benefits. I think of weather data as a decision support tool, and we have several station data networks that you can use. So you can find a station that's near your farm or your area of interest, and then use actual real-time data with these tools that will tell you things like what's the water deficit in this area and at this station location, or how do I think about treating apple scab or any of these pests and diseases, and that necessary information is matched with the actual weather data and can give you really, really important information that's helpful to help support decisions. I mentioned the 5th National Climate Assessment. This is new, came out in November. It is a very robust report. It's written by about 500 scientists, and then we have another 250 scientists that are involved in technical review and contributions. There's 32 chapters. There's one on the Northeast, which I encourage you to consider looking at, and there's also an interactive atlas. So you can look at some of the same data that we used to write the National Climate Assessment, and you can play with it yourself and determine what the projections are for your area of interest. This report is written to be focused specifically on the impact of climate change to our country. And there's a lot, it's also meant to be very easy to access so that you can search. It's really meant online. There are PDF versions as well. There's webinars, and you can listen to it as an audiobook. I haven't done that yet. But there's a lot of products that you can engage with that are related to the National Climate Assessment. So that is what I have for slides. I would love to hear any questions that you have. I posted, I wouldn't expect you to write down this link, but if you just know that we have a newsletter called the Quarterly Harvest, you could Google it and sign up for it. That's going to be most interesting to those who agriculture and forestry, that covers both. I did put a link to our Forest Pulse for those who are interested in forestry issues. That's actually a news brief. So looking at what the media is reporting on climate change, forests, and carbon. And this is sometimes it's also specific to our region, but sometimes we're influenced by outside of the country and around the world as well. Sorry, in the other parts of the country and around the world. So if you're interested in forestry, I encourage you to sign up for that one as well and check out our website. Thank you for listening. I can stop the slideshow and say hello.
Hi, Erin. This is Liza talking. Thank you so much. If anybody has a question, I can pass around the mic, but actually I have the first question. Erin, would it be possible to get a copy of your slides? We're having a little technical difficulty with making them big enough on the screen, and I was just wondering if we could send out a copy to everybody later.
First, yes.
Great.
I can do that.
Thank you. Does anybody else have a question? Down there. Hang on, I got to walk the mic over.
Hi, has there been any research done on the effects on the mycelium networks as well to maintain the soil in terms of climate change?
Do you mean about influencing the networks, or about
how it has negatively influenced or positively?
Yes, although I will say that we in the Climate Hub have not engaged in that research, in part because we focus on management. So again, that working lands component. And so there has been some work on adding microbes, for instance, that would encourage the networks to increase. Although I don't think there's anything on our website about that, and it certainly could be added and considered for sure. But that is a hot topic for research in this area for sure, especially more from a natural science perspective.
I meant more specifically with no-till for being effective for that.
Okay. With any studies that are specific to no-till. We actually have one study that is fairly robust on the economics of soil health. And so we have soil samples from across the country, well, across the Northeast and the Midwest, sorry, where we have looked at no-till versus conventional, and then there's also some cover crop data as well. And they have analyzed soil carbon, organic matter, and we've started to look at yield changes as well. So thinking about how economically feasible is it to do no-till versus not in relation to soil carbon, in relation to yields. But that study does not, and I believe the soil samples were too old by the time we got them to actually analyze for doing an ecoplate analysis, for instance.
Thank you.
Thank you very much. Does anybody else have a question? Hang on, I gotta walk the mic.
Hi, I've noticed that wind speeds are increasing a lot, and I was wondering if maybe local farmers could respond to this also. Does that put at risk your tunnel houses, and is there a lot more damage to greenhouses from the higher wind loads? Thank you.
I want to hear from farmers too, but I will say that I've noticed that as well, and I have not been able to find research on it. In fact, the research that I found has said the opposite, that the increase in temperature will actually cause more of a global stilling. But I think it's that increase in storms that is increasing wind. But I'm very interested in that as well, because I agree. I've seen that a good bit.
We'll ask them when they come up.
Okay.
Does anybody else have a question for Aaron? No? All right, well, we can bring up our farmers. You guys want to come sit up here? There's mics up there. Thank you very much, Aaron.
Thank you. Do you want me to stay on?
I'm going to turn the lights on too. Also, Vero Farm very nicely bought cookies. If anybody would like one, they're in the back. All right, we're just gonna do a brief introduction. We have Brian Kramer from Hutchins Farm, Lisa, I can't remember your last name. Holdorf, there we go, from Barrett's Mill Farm. We have Dan from Walden Woods, and of course we have Steve Barrow from Barrow Farm. Brian, you want to just start? We'll go down. We'll just do a brief introduction about farms, sort of some stuff we've been noticing, and maybe talk about some strategies that you guys have been using on your farms, and then we'll take questions.
So my name is Brian Kramer. I've been at Hutchins Farm for, I think, 19 years now. And we cultivate maybe 50 acres in a year. We manage over 100 acres, but a lot of it is in cover crops. And a lot of it these days is sitting wet under that much water or more. And we are one of the older organic farms in the state, and certainly one of the bigger ones in the eastern part of the state. We grow vegetables, we grow a few perennial fruits, but it's mostly an annual. We have asparagus and a few apple trees, but mostly it's annuals. Yeah, I'm sorry. Yeah. I think I'm scared of the sound of my own voice. As far as I hesitate to attribute anything directly to climate change. because I live day to day in a kind of a weather universe. I attend to the weather probably much more than many other people do. My memory for weather is, I remember how it was in 2009. I remember how it was in 2016. To me, I mean, the farm that we farm next to the Concord River floods frequently recently, but infrequently in my entire experience of 19 years, which isn't that much. The water table on the farm, because it's adjacent to the river, is high, and that means when we get these enormous rain events, it renders a large portion of our farm unusable for a certain period of time. And if we get rains on top of rains, that could take a large quantity of acreage out of contention for an entire growing season, which certainly happened last year. But to me, the most alarming thing about the way things seem to be going is kind of the chaos and unpredictability. I encourage people, we talk a lot about averages. I really appreciate the work of scientists like Aaron, but a lot of times we're dealing with averages, and it's these little outliers that can be really critical. If we think about the winter of 2003, when it was just as mild as it was this winter, except for 2 days where it went down to negative, I think it was negative 13, 2 days in a row. And then we had a freeze in May, which is, extremely unusual. And these kind of events can kind of throw a wrench into, particularly if you're dealing with perennial crops. We're talking about apples and things like that, that kind of have an expectation. I'm sure they have, strategies of their own to deal with variations. But when you get these extreme variations, it becomes very difficult to kind of predict anything. And it becomes, mitigation is difficult if you don't really understand what you're up against in any given year. I mean, it's to me, I've got this, 2023 was extremely wet. 2022 was extremely dry. 2021 was extremely wet. If it went like that, I might be able to understand how to plan, what fields to actually schedule, but it doesn't go like that. There were 2 extremely dry years in a row in very recent memory. Planning becomes very difficult. And I think the psychology of it is difficult because you just, you're led to believe that the world is a certain way, and you're led to believe that, have an expectation that this is X, Y follows X, right? Yeah, Y follows X, X precedes Y, and it's not necessarily that way. Anyway, I'll shut up now.
Please keep going. I'm not ready. I'm Lise Holdorf. I farm at Barrett's Mill Farm. I've been farming in Concord for 10 years now. And we have about 14 acres, and we are certified organic. We grow mostly annual vegetables and flowers. We do a little bit of like strawberries and watermelon, but less so of those things as it becomes more difficult in this climate and with our soil to do. So we are farming on town-owned land. We don't own any of the property or the infrastructure, but we do own like our equipment. So we have one of our strategies that we have been using for the past couple of years. We have built several high tunnels using funding from NRCS. And that has really been a game changer for us. And it's not by any means like the solution, but it has really helped us to deal with the problems of excessive rain in particular. And we have very, very sandy soil, so we are used to droughts, and even with the amount of precipitation, even with how sandy our soil is, like the amount of precipitation that we got last year was really too much for even our sandy soil to handle. So the high tunnels really provide this protected growing space that we can control how much water we give our crops, and which is really important for our high tunnels don't flood, for instance, and we also don't, because the rain isn't falling directly on the crops, they're not getting like pummeled by really hard rain. We don't have erosion in the high tunnels. We also see less disease pressure. A lot of diseases are spread by water droplets. So we grow our tomatoes, cucumbers, and peppers in our high tunnels in the summer. And we're starting to kind of push into later into the fall and into the winter and early spring with growing greens. Like right now we're harvesting a lot of spinach and arugula and kale mix. So it has the added benefit that it like also extends your season and provides kind of like a more continuous income source when you have so much uncertainty about what's going to happen year round. So I would, we are in the process of trying to build a couple more high tunnels to kind of really, we can grow so much more in our high tunnels, like small area, than the yields are just much better. So that's kind of the direction that we're moving. We also, other strategies that we use, we do a lot of cover cropping and have since the beginning. We are constantly every year trying to push and do more and more. So we started actually like undersowing like clover and a bunch of different crops that, like your late fall brassicas that don't come out of the ground until it's too late to establish a cover crop. We've been doing like clover underneath, seeding that in September so that there's something covering the ground. So we're seeing less soil erosion over the winter. We've also gotten a grant in the past to dig a well, and we have another one in cooperation with the town to do a shallow well, like what Aaron was talking about, to be able to get water to reach more of the property. If we have, it feels now like we're never going to have a drought again because it's been so wet, but we know that that's not the case. We know we will see drought again, and so in order, when you see these extreme droughts, it's so important to be able to like irrigate really effectively and be able to cover acreage. And the one well that we have right now is just not enough to cover the whole property. So we're hoping to have another one installed soon for the next mega drought. That's what I had to do.
Hi, my name's Dan Schmidt. I work for the Walden Woods Project, and we have a farm that we bought to preserve the land on Route 2. It used to be called Pine Tree Farm. It's owned by the Amandalias. And they started farming it in, I think, around 1930 and grew corn on the property basically until shortly before we bought the property. So the soil was pretty degraded and not a lot of organic matter. So I started, I think, about 14, 15 years ago, working on it, and Jack Mandalia we bought the equipment with the farm. I had no background in farming, and he showed me what he did, and then I decided I wanted to be organic, and that was sort of not in his wheelhouse. So I was sort of left to my own devices at that point. I don't remember. It's just the last few years where I've sort of been despondent about what's happening with the property and I mean, like 2 years, last 2 years been so wet that at the beginning of the season last year, we borrowed generously from Hutchins Ripper, which is sort of a device so that you can loosen the soil and get down to your hard pan, basically going down a couple feet. We did this over the entire property, and I had done it maybe, I don't know, 7 or 8 years before. And by the end of the season, it's like we never did anything. I think in some ways it was worse. We had so much water, you know, basically every weekend there'd be 1 or 2 inches, 3 inches of rain, that it went down all these new pathways and just everything got harder, made even maybe more hard pan. But I don't have a lot of answers. I mean, I have more questions. I mean, for instance, we have wetlands around our property. We have like maybe 5 to 7 acres that we are using for farming. So we're organic. We're probably the smallest. We're definitely the smallest of all the farms that are represented up here. And to the edge of the fields, there's a wetland. And for years, there's been nutsedge, which is a kind of sedge that normally grows in wet areas. And the last couple of years, it's now moved into a bunch of our fields, and it's just horrible stuff. We have some raised beds that have plastic, and it just punctures right through it. And you know, since I haven't really found an organic solution to that problem, so we're fortunately able to move into other fields that don't have it right now. The greenhouse, the hoop house idea sounds like a really maybe good alternative or good direction to move in. I just sort of wish I had more optimistic feeling about, you know, a solution to dealing with changes in climate. I mean, like 3 years ago, it was very dry, and that was a great year for us because we have a well and we have a pond that we're able to irrigate from, and so we could control the water. But this last couple of years, it's been just so much rain, and I think some crops do well in the wet weather, and maybe we move more towards that. I've heard that the nutsedge has a tuber, right?
Yeah.
Apparently they're edible, right?
Yeah.
So we may have to turn into a nutsedge farm. I don't know.
How you harvest it though, it's so wet.
I don't know. But anyway, I'll be interested to see what Steve has to say.
It's working well. Might as well keep using it. I'm Steve Verrill from Verrill Farm. We have a family farm with my wife Joan and daughter Jennifer and her husband Tim. They're all floating around here someplace. The farm's been in operation for a little over 100 years now, and a lot of it used to be Wheeler Farm and various branches of the family. So we're the second generation or second owners since the Indians on a lot of the land, I think. Most of the land we own, we put in an agricultural preservation restriction about 40 years ago, so that there's excellent farmland and it'll stay as farmland. We grow a variety of vegetables. Actually, the guys are planting a new asparagus bed today, started that. That's the first crop that comes, but unfortunately the bed they're planting today, we won't get much off for 2 or 3 years. Takes a long time to get one established. We talk about climate change, and I think more accurately, it's climate changing. Um, That seems to be the constant case. I know there's been a general warming trend because I remember about 85 years ago, the plow banks and the snow were always over my head. And I haven't seen them up there lately. But there definitely is a warming trend, but it isn't dependable enough to amount to much in terms of crop production. We used to figure the last frost was Memorial Day. After that, it was safe to plant everything. And I still keep that in the back of my head, but usually we don't get much after the middle of May now, but we could. And that's why, like with our tomatoes, we put out 4 plantings of tomatoes. We gamble a little bit with an early planting, and then we put out a main planting, and then a later one, and then a late one. And that gives us insurance against the unknown weather that we're going to have. And it also helps a lot with disease insurance. Not you have to insure against disease because you know you're going to have them. But some of the things that come along, no matter what you do, you can't stop the blight. So we keep having a new planning coming along down the road. So that covers that. But then it was mentioned earlier, I think actually Brian took a lot of my talk. But we've seen this last year was extremely wet. The year before, as it was mentioned, was dry. The winters have been getting warm, but last year we had a freeze that nipped all the peach blossoms and the buds in February, so there weren't any peaches at all in Massachusetts or any place north of here. And peaches are an interesting crop because one of the parts of their cycle, they need a certain number of cool days, the chill period they call it, with temperatures below 45 degrees. And if they don't have that, it doesn't work for them. But that's not the same for all varieties either. And it takes considerable time to establish peach trees, just like it does asparagus. And people can't just jump around and say, gee, it was a different winter, we need to change a variety this year, and then next year they get nipped on it. So these are some of the complications we run into. And we do a lot of raised beds. On our land, we have some dry highland that we rent mostly. And then most of our land is lower valley and river bottom and lake bottom land. It's very productive as long as you don't get too much water. And one way we've compensated for that is to use raised beds. We have a machine, we go along with a tractor and it'll build a bed that's raised up about 6 inches. And that way, when we get a rain, it can shed some extra water. And we don't have to worry about that so much. And the roots are usually in a modestly dry area. And we plant most of the small things like lettuce and beets and carrots and all that kind of crop on those raised beds. Then to go a step further, we do raised beds covered with a plastic mulch with a drip line under the plastic. And that sheds all the rain from the bed when it rains heavily. But some of it will seep back up underneath in a heavy rain. We have the drip line under the plastic. We can turn on our water. We have it all hooked up whether we need it or not. So we just have to turn it on and we can water it for 6 or 8 or 10 hours, whatever we need to get water down to the root zone, and then turn it off. So that is pretty good insurance against a number of things. Strawberries are one of the things we grow quite a few of, and one of the main risks there is the frost damage in the spring from the, if the buds get frozen, you don't get a strawberry. If I mention yeah, what was that word? It'll come to me. It's a definition. I was going to ask how many people remember for chemistry that I did up until a few minutes ago. When you are going to freeze water, you can cool it down like from 50 degrees to 40 degrees and from 40 down to 32. But to turn it into ice, it takes a lot more cooling than it does to cool it a couple degrees. And that makes that a valuable thing for frost protection. You can spray a little water on the strawberries and it won't freeze until it's been there quite a long time. And as long as you have a little bit more water coming, you can build ice up. I've seen the beds past years, we've had the leaves and all covered with like 1/8 of an inch of ice. And you can flick that off and hold it. It's a molded piece of ice. But there was wet water, so it didn't go below 32. And the blossoms will take it down to about 30 or 29 degrees. So it's that narrow thing you're working with. But that means you have to turn the water on before it gets cold enough to freeze the buds. And for years, if we're going to have a frost, we've gone out at 3 o'clock in the morning and checked the temperature and turn it on if we need to and go back to bed if we don't. But this last year, we should have been out at 11 o'clock at night because one of our fields, we had water set to go and it was too late. So we had some serious frost damage there. We had the other field covered with a remay row cover, which is another protection against frost. And you can put that on if they forecast a frost and go to bed and wake up in the morning and probably be all right unless you had a hard frost, because that'll protect it from frost for 3 to 5 degrees. But if you have a colder frost than that, you might well not have done it. So either one has a drawback, but some of these lines are very sensitive on how you're dealing with things and frost protection and so on. 2 of our fields that used to be part of the Wheeler farm were tile drained over 100 years ago. There were clay tiles. They looked like the clay in a flower pot. They're about 1 foot long, and there are no bell joints on them or anything. They just cut off square and butted against each other. 1 foot pieces, and one of the fields on Wheeler Road, they go all across the field down to the brook, and there are about 20 lines in that field that are still working. And that makes a big difference. Sometimes in the spring, we'll see the water come up when the frost just going out, and we'll see there's one damaged tile, and we can dig it out and fix it. And that does it. Well, I didn't use any of my old notes. And the word I was trying to think of was coefficient of freezing. So do you remember that from your school? We used to learn things in high school. Well, we're gonna go to questions here?
Yeah, we're gonna go to questions. I was just asking, reiterating your question from earlier, do we want to just, you guys quickly mention the effect of storms, like on high tunnels? Has that been an issue on greenhouses? Like heavy rains, obviously that's been an issue, but have you felt with increasing storms and the intensity of those storms, you're dealing with particular issues around infrastructure? Lisa's nodding.
We've always been worried about having wind damage on our high tunnels. And we did have one instance where the plastic covering on our high tunnel just there must have been some like strange little microburst because I was like out biking with my family. It was a totally nice day in May, and we came back and just one of the high tunnels had the plastic just ripped completely off of it. The others were fine. And we had, you know, some of our row cover had blown into a tree. We had to get a cherry picker to the farm to get the row cover down. But that's the only so far damage that we've had to high tunnels, and the structure was fine. It was just the plastic is a pain to take off and reskin it, but no problem with the structure. We actually had the worst wind damage this fall when I don't know if you all remember that storm that just came through. It looked, the sky turned green. And we have a tent where we do our CSA pickups, and that just got completely destroyed. So that was the worst infrastructure damage that we've had from wind, I would say.
I'm gonna say that storm was the day before Ag Day last year.
Yes.
And we almost lost, we almost lost all these sliders off of our farm stand. I was like, is this a tornado? What is happening? It's horrifying.
Yeah, the wind is scary. Heavy snow can be extremely scary for hoop structures as well. So it's rare, seems to be rarer now, although I've certainly seen lots of snowbanks taller than Steve even is now. No less than what he was 85 years ago. But I've seen greenhouses crushed. This is one of the reasons that I am kind of scared to go into the high tunnel business, is because every time we have a huge storm forecast in January or February, I'm like, thank God I don't have a high tunnel. Because I've had to shovel out these things as well, which is not fun. But certainly, you know, feet of snow, they engineer them quite well. But, you know, these days things are very unpredictable. So you get the last huge, you know, blizzard year we had, where we were getting, you know, close to a foot every week. It was very cold and very dry all winter, and this wasn't that long ago. It was like 2009, something like that. 15. Well, there were two of them, but anyway, the earlier one was worse. And you know, the snow was so light, it's blowing around. I dug out most of the greenhouses, but one of them I just left. It seemed to be fine, and then it started raining, and all of a sudden the snow that weighs, you know, ounces per cubic foot now weighs pounds per cubic foot, and you know, metal tubing is actually very ugly when it's bent and like crushed. So
Maybe I don't want more high tunnels.
That scares me.
We can ask other questions too, unless you guys want to talk.
We did have a greenhouse collapse a number of years ago, and we have some plastic houses now, and we do go through in the fall and stand up 2x4s down the middle of them. Yeah. And that seems to help.
Plastic is cheaper than the whole frame.
Does anybody else have a question?
Hi, I guess this is a question also for Erin, but Liesel mentioned grants. Is there an aggregator where farmers might be able to access grants, especially for climate change mitigation or things like that?
I'm not entirely sure what you mean by aggregator, but we do have a place on our website where we have collected information about financial assistance for farmers and forest landowners that are related to climate mitigation. Oh, sorry, adaptation. Mitigation might be coming down the line, but right now, climate adaptation. So building resilience. That I can try to put the link or send it to Lisa. Is that what you meant? So like it's like a spreadsheet where you can search for different elements of financial assistance and all the different opportunities are compiled there.
Yes, thank you.
Yep.
Anybody else? Hey, Karen.
With the climate change, the heat going up, do the zones also reflect that? Because I live in Acton and I'm a zone or have been in zone 5, but will my zone be changed? So what is it now?
Well, the thing about the zones is that the zones are trying to help you determine what you can grow reliably based on averages and maximum and minimum temperatures during different times of the year. Sorry. But I think the thing about unpredictability, as we saw last year in May, I mean, I don't know if it was in the 20s when your strawberries got destroyed last year. And so there's always curveballs. So even though we're now in zone, what, 7A now, I think? 6B? It doesn't mean that I mean, it's like first and last frost dates. There used to be the, kind of, this is the last frost. You're not, there was a average last frost, and then there's a frost-free date that's like 2 weeks later or something like that. But I wouldn't put my money on that anymore because you just have these events that are kind of anomalous, or maybe they're not anomalous, but they're very unpredictable. And so, yeah.
So you don't believe in the zones?
I believe in the zones. I don't pay a whole lot of, I've not started, we do a little more okra than we used to, but not a lot. Although I will say, when I first moved here, it didn't seem like very many people grew sweet potatoes, and now everybody grows sweet potatoes. So there is some movement to take advantage of kind of the increasing heat units that you can generate during a growing season.
Anybody else? Hi.
Hi. In some ways, I think a lot of farmers sort of feel that the use of plastic is sort of a deal with the devil. And are you able to reduce the amount of plastic you use for mulch, or is it something that we just have to accept?
We have to use so many square feet of it or miles of it. And we use a pretty thin mulch, so I think 1.5 mil in that area. So that reduces it some, but unfortunately, there's no way to recycle it around here, or either through use or reuse. That's a drawback.
So, yeah, plastics definitely deal with the devil. But the more that I use it, some of the effects of heavy rain has to do with extraordinary leaching of fertility. So nutrients that either we put down or we try to encourage our cover crops to produce in the form of nitrogen and phosphorus and so forth, some of them are extremely leachable. They're soluble, and you get these heavy rain events of 2 and 3 inches. And basically, you put down all this nitrogen is now in the river and heading towards, wherever the river ends up. One thing that plastic does, plastic has a reputation, black plastic in particular has a reputation of warming the soil, keeping down weeds. The longer that I've been farming, I feel like the most important thing that plastic does is it maintains an environment where it's not too wet, not too dry. I mean, it can get very dry, but it also holds the nutrients where the plants are going to use them, and they don't leach into the groundwater. I know it's not ideal, but I'm dependent. I admit it. This is like a plastic users anonymous.
Yeah. You're not alone. I just putting in the chat box. I don't know if you guys can actually see it, but I can send these links. We have a resource on logistics costs and benefits of we call it tarping, but there's a lot of it has to do with plastics, and and there's also an economic tool that's on this website to kind of give you a sense of what the trade-offs are, and then there's many different resources that are cited here. So if you're curious about the research behind this, I would say that story that you just gave has been told many times and is shared by many farmers.
Great,
including myself.
Daniel.
I mean, I don't know a lot about it, but there are, I mean, they keep talking about biodegradable plastic. I don't think it's organically certified. I don't know if it's just as bad as regular plastic. I don't know, maybe someday something will happen with that.
Yeah, I think most of the biodegradable that's on the market now is tiny pieces of non-degradable plastic glued together, and I think it's the glue that degrades, is my understanding. So you get pieces you don't see much, but it's in the soil.
I think Steve is right.
Sorry, I spend endless hours picking teeny pieces of plastic from people that throw their stuff out the window on Route 2 to when you use the plastic, you're punching through it in a little piece sometimes. So yeah, it's terrible.
I don't understand if they can make pajamas out of bamboo and various things out of hemp. Can't something like that be used?
I don't know. I don't know that there's enough bamboo when you consider the plastic usage, in the country. In Florida and California, when you consider the amount of plastic mulch that's used,
yes,
it's enormous.
So, I don't know. I mean, bamboo and what was the other one you mentioned? Hemp, right?
We should all donate our clothing.
Well, that's the thing. That would be wonderful if we could recycle this stuff into something that would be usable.
Is there another question? I thought it was, yeah, hand raised.
I wondered if any of you could comment on the increase in pests that you can attribute to climate change or erratic weather patterns. Are you noticing more pest pressure, and what are some of your solutions for it?
One thing I realized as I was thinking about this presentation was there are a bunch of new pests. So within the time I've been here, we have become the proud, or whatever, the home for basal downy mildew, downy mildew of cucumbers and cucurbits, which used to be very uncommon, spotted wing Drosophila, which was mentioned by Aaron, which is a pest of mostly berries. What else? Come on, help me. Allium leaf miner, Swede midge, leek moth. Anyone?
You're doing great.
I can't attribute any of these directly to climate change. A lot of it may be globalization and free trade increasing. But what I realized, so I have a field that's basically underwater right now that I try to use, and it eludes me. But I keep trying, maybe because I'm silly. But anyway, there's still leaks in there, okay? So leaks are a host of this new, very difficult to control and damaging pest called allium leaf miner. And as the scientists at Extension would tell me, and I mean, God bless Extension, I love Extension, they would tell me, well, you got to plow that stuff in, you got to kill those things so that they don't harbor pests, you know, into your crops. Of course, they survive the mild winter, which they often do, even if it's not that mild. But anyway, they're growing in a swamp. They're very much alive, these leeks. They're doing me no good. I can't harvest them. They're disgusting, but they're alive. And I can't plow them, and there's no way for me to kill them. So they are actually going to be a host for what will, for me, will be the first real generation of allium leaf miner that we've seen, which is a newly arrived pest. And I'm looking forward to the challenge. Yeah. Which I'm just kidding, I'm not.
Well, I'm just going to talk about high tunnels. So we have started putting up this netting on the sides of our high tunnels that will exclude a lot of pests. We don't grow a lot of the crops that you were mentioning that have these particular new pests, but that is kind of how we're dealing with increased pest pressure. And yeah, it's always just been like exclusion. Pest exclusion has been we don't, as Brian has said before, for organic farmers, we just sprinkle fairy dust on we don't really spray effective pesticides. So exclusion has always been our strategy for dealing with pests.
I mean, there are different varieties of seeds that are attempting to deal with, like, for instance, basil, it's downy mildew, and there are new varieties of basil that are what? Not anymore?
No, you're gonna badmouth.
Yeah, but the problem is they don't taste as good, so.
Now we're not gonna sell them. I think if you have basil that's not so good, it's better than no basil.
It's fine in pesto.
I think we need to train the New Jersey farmers a little better. One of our biggest pests is the corn earworm, and that seems to come in when we get a southwest wind and a storm coming up from New Jersey. Our crop scout has traps out to monitor the moths. Invariably, after a storm like that, there'll be a lot of moths in the trap that weren't there the day before. That means that they're going to go lay eggs in the corn silk, and they'll hatch in 3 to 7 days, depending on the temperature. And we'll have to spray to kill them before they hatch and crawl down in, unless we're all ready to pick it. Then we'll let you look for them.
One more thing to say about pests is, so typically New England has been spared certain diseases and pests because they don't overwinter here because we have severe winters. So corn earworm is a pest. So corn European corn borer actually will overwinter here and comes up with your first planting of corn. But corn earworm is always comes up from the south where it reproduces because it's warm enough. So, and then late blight is a disease that blows up, all the downy mildews tend to blow up. They are unable to sexually reproduce in our climate as it exists right now because of, I think, temperature extremes. But if our average winter temperatures go up enough, we will start to have these sexually propagating diseases and insects. And insects are just big diseases. That's all they are. In terms of from a plant's perspective, they're all pathogens, you know. So, I mean, that's something to be worried about.
Anybody else with a question? No? Thank you guys very much. Thank you, Erin. Thank you guys very much for coming. And we'll get the slides from Erin too, so we can send them around so you guys can take a better look at those maps. And please help yourself to cookies in the back, please. Thank you all for coming.
Thank you. Good night.